Hello everyone. This video would focus on conic section, specifically on ellipse with center at 0, 0 or at the point of origin. And this is the 10th part. In this part, we're supposed to determine the standard equation of an ellipse and we're supposed to graph it. And in this problem, we are given the center, one of the two vertices, and one of the coordinates of the two foci. Before we go over this example, let's have a review on the parts and the two cases of an ellipse with center at 0, 0 or at the point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex. And we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that again, our A is always greater than B. Now to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now let's go back to the problem. Okay, going over this problem right here, we are supposed to sketch these 3 given coordinates here. Our center is at 0, 0, so I'm going to label this as our C. The vertex, one of the vertices, is at 0, 8, so that would go up here. So this is 0, 8. This is one of the vertex. Now we remember that the distance from the center to the vertex and the distance from the center to the other vertex would be the same. So this tells us that it's gonna go down 8 as well. So this is where our other vertex is gonna sit. So we can go ahead and add the other coordinate of the other vertex, which is at 0, negative 8. We also have the coordinate of the first focus, 0, 2, square root of 7. We can change this to its decimal version, that is 0 and 5.29. So I go ahead and sketch that up here. So 5.29 should be somewhere around here. So this is our first focus, and this is the other focus right here, 5.29. So that's the other focus down here. Now, looking at this problem, we can go ahead and say that the other coordinate of the focus is, that's gonna be 0 and negative 2 square root of 7. Looking at this, we can tell that our ellipse has a center of 0, 0, or at the point of origin, and this is a vertical ellipse. So I'm gonna go ahead and write that information up here. Since this is an example of a vertical ellipse, I'm going to write the general equation of a vertical ellipse down here. Now notice that our a squared is placed under the y squared because again, this is an example of a vertical ellipse. Now looking at this, we can go ahead and say that, remember that our a value is the distance from the center to the vertex. So we can use the distance formula between 0, 0 and this coordinate right here to determine the value for A, or our A, actually we can go ahead and count it. This would be 1, 2, 3, 4, 5, 6, 7, 8. So that would be a plus minus 8. So this tells us that our a squared is 64. So I go ahead and plug that 64 into the a squared right here. So our equation will come out. Now notice that we don't have a b squared, but then we are given the focus. Now we remember that the distance from the center to the focus is actually represented as letter C. So I can go ahead and write that down here, that our C, we can use the distance formula, or we can get this value right here. So we can go ahead and say that the C is actually 2 square root of 7. Now, we don't want the C. C is not included in any of these. But then we remember that we can solve for b squared using the equation c squared equals a squared minus b squared. So I'm going to go ahead and write that formula up here. Since we have a c value, so I'm gonna plug this into the c here. So that is 2 squared of 7, and then that is squared equals our a squared is 64 minus b squared. We distribute the squared here to both of these so that this comes out. 2 squared is 4 times square root of 7 squared is 7 equals 64 minus b squared. So 4 times 7 is 28 equals 64 minus b squared. We wanted to solve for b squared. So I'm going to go ahead and add b squared to both sides. So that's plus b squared. So that we can cross the b squared out. We are left with b squared plus 28 equals 64. And then from here, we can go ahead and solve for b squared. So I will show that work up here. So this comes out. Our b squared value is 36. So I will put that in here. That's 36. This tells us that this is the equation that will work for this problem that we have up here. Now, we know that the distance from the center to the co-vertex is represented as b. So I can go ahead and say that I go 6 left, 6 right from the center, and that is our co-vertex gonna sit. So the first co-vertex is gonna sit here. So this is the first co-vertex, and then the other co-vertex is gonna sit on this side right here. So we can go ahead and sketch the ellipse. Okay, so then we can go ahead and say that the coordinates of the two co-vertices would be these two right here. So that is located at -6, 0, and the other co-vertex is at +6, 0. So this is the equation that would work for this problem right here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're given the value, the center is at 0, 0. So I'm going to label that down here. And then our vertex is at 7, 0. So that's going to be 7 and 0. This is the first vertex. And then the other focus, we can change this into its decimal form. That would be 4.90. So I'm going to go ahead and plot this dot right here. So 4.90 should be somewhere around here before 5. So I will have this as the first focus. So that's letter F right there. Now, we remember that the distance from the center to the vertex and the distance from the center to the other vertex will be the same. This tells us that the other vertex sits on the opposite side. So that would be on -7, 0. So I will put this as the other vertex. So this is also going to be -7, 0. And then the other focus is located on the other side from the center. So that would be located somewhere around here. So this will be the location of the other focus. And so the other coordinate of the other focus would be, that's going to be -2 square root of 6, 0. Now looking at this, our center is at 0, 0, or at the point of origin. And since our two vertices are horizontal from each other, so this is an example of a horizontal ellipse. So I'm going to go ahead and write that information up here. Now notice that the a squared is placed under the x squared because again, this is an example of a horizontal ellipse. So we can go ahead and say that our value for a, remember that a is the distance from the center to the vertex. We can use the distance formula to determine the distance between these two, or we can go ahead and just count it. 1, 2, 3, 4, 5, 6, 7. So our value for a is 7. So I'm going to go ahead and write that up here. This tells us that our a squared is 49. So I will plug that 49 into the a squared right here. So our equation will come out. Notice that I did not write anything to the b squared because there's no value for b squared given to us. But we are given the focus. Now we remember that the distance from the center to the focus is represented as letter C. So we can go ahead and determine this distance using the distance formula. But the easiest way to do that is that's actually this value. So that's 2 square root of 6. So our C is 2 square root of 6. Now we can solve for b from here. That is using the formula c squared equals a squared minus b squared. So I'm going to show the work down here. So we have solved the value for b is 25, or b squared is 25. So I'm going to plug that in here. So this is 25. And so we can go ahead and say that this is the equation that would work for this problem that we have up there. Now we say that our b is the distance from the center to the co-vertex. So I will count 5 up and 5 down to plot the co-vertices. And I will write the coordinates of the two co-vertices down here. So this is the equation that would work for this problem right here. And this is the graph of this ellipse that represents this equation. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya.